Today, we will be talking about logical analysis of concave polygons. Now, the previous video that I have made is about logical analysis of convex polygons. However, today we will be discussing the logical analysis of concave polygons. So let's get started. Now, on this whiteboard, we have 4 statements, and let us read each and every single one of them together. And then I'm going to be drawing 3 separate polygons, all of which are concave, and we will analyze each one of them in detail. So statement number 1 states that a polygon is concave if it has at least one interior angle that is greater than 180 degrees. Statement number 2 states that a concave polygon must have at least 4 sides. That's right. The reason why that is the case is because triangles can never be concave, because all their interior angles must add up to 180 degrees. Statement number 3 states that in a concave polygon, there must be at least one case where it is possible to draw a straight line that connects 2 points of the polygon with that straight line passing through the outside of the polygon. And last but not least, statement number 4 states that if there is at least one case where it is possible to draw a straight line that connects 2 points of the polygon with that straight line passing through the outside of the polygon, then in that case, at least one interior angle of that polygon must be greater than 180 degrees, not greater than or equal to 180 degrees, but strictly greater than 180 degrees. So now I'm going to erase the title in order to make space to draw 3 polygons, all of which are concave, in order to illustrate this example. So first of all, let's suppose we have this random shape right here. Let's suppose we have this shape right here. So that's the first polygon, which is concave. The second concave polygon that I'm going to be drawing right now would be this one right here. And the third one, let's suppose we're going to have a very weird concave polygon. For example, the one as follows. Yep. So let's suppose we have this. Now, actually, I'm going to modify it a little bit. All right. So we will now examine how each one of these three concave polygons satisfies all four of these definitions right here. So statement number one states that a polygon is concave if it has at least one interior angle that is greater than 180 degrees. And that makes perfect sense because if you take a look at each one of these three concave polygons, right here, we have an interior angle that is greater than 180 degrees. For this second polygon in the middle right here, it also has one right here. Now this one that's to the right side of the whiteboard, it has more than one interior angle that is greater than 180 degrees. It has one right here. It has a second one right here. It has a third one right here. And it has a fourth one right over here. Now, let's take a look at statement number two. Statement number two states that a concave polygon must have at least four sides. And let's take a look. This one has five sides. It has one side right here, a second side right here, a third side right here, a fourth side right here, and a fifth side right here. This one has exactly four sides. 1, 2, 3, 4. And this one has a lot more than just four sides. It has, just going to change the color of the pen. It has one side right here. It has a second side right here, followed by a third side right here, a fourth side right here, a fifth side that is right over here, a sixth side that is over here. There's a seventh side right here, an eighth side right here, a ninth side right here, 10th side right here, and last but not least, an 11th side right over here. Now, statement number three states that in a concave polygon, there must be at least one case where it is possible to draw a straight line that connects 2 points of the polygon with that straight line passing through the outside of the polygon, not through the inside or on the boundary line of the polygon, but through the outside of the polygon. So let us put statement number three to the test. So As for the first polygon on the left side of the whiteboard, we certainly have a case where we can connect 2 points of the polygon where that straight line passes through the outside of the polygon. Right over here. That's the one and only case. And therefore, it matches the definition of at least one case. What about this polygon right here that's in the middle, the second polygon? Yes, there's just one single case only, and that is connecting this point to this point. And of course, it is obvious that for the third polygon right here, it has multiple cases. It has one case right here. So that's the first case. Here's a second case. Here's a third case. Here's a fourth case. And last but not least, here is a fifth case. And we will read the last statement, which is statement number 4. Statement number 4 states that if there is at least one case where it is possible to draw a straight line that connects 2 points of the polygon with that straight line passing through the outside of the polygon. So once again, it has to pass through the outside of the polygon, not inside of the polygon, and not on one of the boundary lines of that polygon, but through the outside of the polygon. Then in that case, at least one interior angle of that polygon must be greater than 180 degrees. Not greater than or equal to 180 degrees, but strictly greater than 180 degrees. Okay, so for all of these statements, for all 3 of these polygons right here, there is at least one case where it is possible to draw a straight line that connects 2 points of the polygon with that straight line passing through the outside of the polygon. And so therefore, you will see at least one interior angle of that polygon that is greater than 180 degrees. Specifically, for this first polygon right here, the interior angle that is greater than 180 degrees is this one. For the second polygon, it is this angle right here. And last but not least, for the third polygon on the right side of the whiteboard, it has 1, 2, 3, and 4 cases where the interior angle of that polygon is greater than 180 degrees. And this is the logical analysis of concave polygons.